Dear students, good morning. Today we read three-dimensional resolution of vectors. Earlier we have read two-dimensional resolution of vectors. A vector equal to ax vector plus ay vector, or a vector equal to ax I cap plus ay j cap. Okay. Today we take three-dimensional resolution of vectors. In this three-dimensional resolution, we take 3D vector. In two-dimensional resolution, we take only two-dimensional vector. It have two components, one component in x direction and one component in y direction. Because it is in a xy plane, we assume that in that condition, this vector OP is in xy plane. So in z plane, in yellow z axis, this vector does not have any component. But now we take a 3D vector. What is the condition here? This is x axis, this is y axis, and this is z axis, perpendicular to the planar paper. Okay, and this is the r vector OP. This plane shows the r vector OP. So this vector is a 3D vector. It have component in x direction, in y direction, as well as in z direction. So finding the component of this vector in x direction, y direction, and z direction. What we do? This is z axis, this is x axis, and this is y axis. First we draw a perpendicular from point P. This is point P on y axis, that is PT line. Then we draw a perpendicular on this xz plane, this line and this line, x line and z line makes a plane here. And we draw a perpendicular on that plane, and n is the point in that plane. Then we draw a perpendicular from n to the z x-axis, this x-axis, and z-axis, this. Then the component on y-axis is OT, and OT is equal to NP here. So OT and NP is AY, and OM is equal to AX, and OS or MN is equal to AZ here. First you understand this diagram very clearly. This is x-axis, this is y-axis, and this is z-axis, perpendicular to the plane of paper. This is our 3D vector. OP, this is point P. When we find the component of this vector on x-axis and z-axis, then we draw a perpendicular on this xz plane. Now, this point N is in the xz plane. From that point N, we draw a perpendicular on x-axis and z-axis. Then OM is the component in x direction, OS is the component in z direction, and OT is the component in z direction. And by the diagram, it is clear that this PN is parallel to TO. So direction, when we take direction NP is directly parallel to OT, and NP and OT are equal. So we can also write NP equal to AY. Like that, this OS and MN are parallel and equal. Then we can write OS equal to AZ, then MN also equal to AZ. Okay, now we take by the triangle law of vector addition in this triangle and in this triangle. We take two triangles. First we take triangle OPM. What is the triangle law of vector addition? You know, it is very simple law. We take two sides of any triangle of same order. Same order two sides लेंगे, and third side is equal to the sum of these two sides in opposite order. Then we take same order sides in triangle OPN, that is ON and NP are in same order. देखिए arrow, you see these arrow, this side and this side. So ON plus NP equal to OP. ON plus NP equal to OP. And we know what is the OP. OP is A vector. What is NP? NP is AY vector. So this is equation number 1. Now in triangle OMN, again we apply this triangle law of vector addition. You find the two sides in same order, then same order sides are OM plus MN. This OM is O to M, MN is M to N. Then OM plus Mn equal to opposite order On. Okay, now what is OM? OM is OS and Mn is AZ, because Mn and OS are equal, AZ. So On equal to AX plus AZ. Now put the value of On in this equation number 1. Then we got AX vector plus AY vector plus AZ vector. This is the, so any vector is equal to the component in x direction, y direction and z direction. Now we know that unit vector is any vector divided by the magnitude of that vector. Magnitude is x. Okay, magnitude of x direction is x. Then this becomes I cap, because unit vector in x direction is I cap. Like that, if we write j cap equal to ay vector divided by ay, and k cap vector is az and magnitude is z. Any vector divided by the magnitude of that vector, then we got unit vector, and unit vector in z direction is k cap, unit vector in y direction is j cap, and unit vector in x direction is I cap. So we can write ax vector equal to ax I cap, ay vector equal to ay j cap, az vector equal to az k cap. Now this is equation number 3. Put the value of ax vector, ay vector and az vector in equation number 3. Then we got a vector equal to ax I cap plus ay j cap plus az k cap. Now here we see that the angle made by this line OP or vector 3D vector OP from x axis, y axis and z axis is alpha, beta and gamma. So we can write that x component ax equal to a cos alpha, ay equal to a cos beta and az equal to a cos gamma. Okay, now if we square and add these three equations, if we square and add these three equations,